Good morning, all of you. In the previous class, we saw the characteristic properties of metals. We saw metals are solid at room temperature, they are good conductors of heat and electricity, etc. Now we are going to learn about non-metals. They have the properties just opposite to that of metals. There are so many metals, but non-metals are only very few. 14 to 15 elements are non-metals. Let's see the characteristic properties of non-metal. What are the examples of non-metals? Carbon, sulfur, oxygen, nitrogen, bromine, chlorine. These things are non-metals. There are solid non-metals like sulfur, carbon. There are gaseous nonmetals. So, nonmetals are either solids or gases. Let's see what are their characteristic properties. Nonmetals, as the name suggests, are opposite to metals, which means that their properties are quite different from the metals. They are comparatively less in number. How many? 14 to 15. 14 to 15. Metals, so many. We know that 92, only 92 elements occur in nature. The remaining elements are either synthetic or man made. Now, only about 14 to 15 elements are nonmetals. The important properties of nonmetals are number one, they are either they are either gases or solids at room temperature. Exception is there. Mainly exceptions are asked in the question paper. Bromine is a liquid. Bromine or bromine is a liquid. Number two, this is exception. Bromine is a liquid is an exception. Next, non-metals vary in color. Solids have generally dull surfaces. They have they have dull surfaces. That is in the case of solids we are telling. They have dull surfaces. Metals we know, that is metals are lustrous, they have a shiny surface. Now here non-metals have means non-metal solids have dull surfaces, but there is exception. Iodine crystals have bright luster. So exception, iodine iodine crystals have bright luster. Number 3, non-metals are mostly poor conductors of heat and electricity. Mostly poor conductors. Poor conductors of heat and electricity. But graphite is a good conductor. So there is exception. Graphite is a good conductor of heat and electricity. Number 4. So mostly poor conductors of heat and electricity. Exception is the graphite is a good conductor. Now, number 4. Most of the nonmetals are quite soft. Most of the nonmetals are quite soft. Exception is the diamond is very hard. Diamond is very hard. Number 5. In the case of metals, we learned metals are malleable and ductile, but here non-metals are non-metals are non-malleable, non-malleable and non-ductile. Non-ductile. Number 6. Non-metals are not sonorous. Non-metals are not sonorous. Sonorous means when hit, when struck, it makes a tinkling sound. Now, non-metals, if you hit it, no sound will be coming. That is, non-metals are non-sonorous. Number 7. You know that metals melting point is very high. Melting and boiling points of metals are very high. But just opposite to that, as compared to metals, the non-metals have very low melting and boiling point. As compared to metals, non-metals have very low melting point and boiling point. Now, what are the examples of these non-metals? Common examples of non-metals are carbon. Carbon may be in the form of coke, 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 coal, charcoal, or nitrogen. Nitrogen, oxygen, bromine, chlorine, iodine, phosphorus, sulfur, etc. Nitrogen, then chlorine, Cl2, then iodine, I2, bromine, Br2, phosphorus, P4, sulfur, S8. These 2, 4, 8, those things we'll be learning afterwards. These are called the atomicity. In one molecule of the sulfur, 8 atoms are joined together. 8 atoms together make 1, 2, 3, 4, 5, 6, 7, 8. 8 atoms of sulfur together make one molecule of sulfur. 8 sulfur atoms together make one molecule of sulfur. Similarly, phosphorus. Phosphorus P, 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 P. 4 phosphorus atoms. 4 phosphorus atoms. Phosphorus, 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 phosphorus. So, P, 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 P. 4 phosphorus atoms together make one phosphorus molecule. So the number of atoms that make one molecule is called atomicity. So this 8 means atomicity of sulfur, 4 means atomicity of phosphorus, 2 means atomicity of bromine, diatomic. So we call them diatomic, diatomic, tetraatomic, or polyatomic. More than three, we call it as polyatomic, polyatomic. So these are the examples or the characteristics. These are the characteristics and examples of nonmetals. Now, one more category we learned in elements. Remember elements? Elements are classified into metals, nonmetals, and metalloids. Now, the third category, what we have to learn is metalloids. There are a few elements which possess the characteristics of both metals and nonmetals. These are actually the borderline elements and are known as metalloids. So, metalloids possess the qualities of metals as well as nonmetals. Elements which possess the characteristics of both metals and nonmetals, or they show the properties in between metals and nonmetals. Such elements are called metalloids. Some common examples of metalloids are arsenic. So, we'll see only metalloids. Metalloids. Examples are arsenic, antimony, antimony, bismuth, arsenic, antimony, bismuth. These are metalloids. They show the properties between metals and nonmetals. So that's about the different categories of or different classifications to which elements are divided. Elements may be metals, elements may be non-metals, elements may be metalloids. So we are again going back to that previous starting matter. Matter, matter is divided into pure substances, pure substances and mixtures. Mixtures we saw homogeneous mixture and heterogeneous mixtures. Pure substances are classified into elements, elements and compounds. Compounds. Elements are again classified into metals, metals, non-metals, and metalloids. Now, let's see the compounds. In what way this blue line compounds? in what way they are classified, what are compounds, in what way they are classified, what are the characteristics of compounds. Let's see those things. Now we are moving to compounds. We are moving to compounds. So matter is classified into pure substances and mixtures. Matter is classified into pure substances and mixtures. Mixtures we have already seen homogeneous mixtures and heterogeneous mixtures. Then pure substances we classified into pure substances are classified into elements and compounds. In elements metals, nonmetals, and metalloids. Metalloids have the properties in between metals and nonmetals. Or metalloids show both the characteristics of metals as well as nonmetals. Now we are moving to compounds. What is a compound? Compound, the typical example of a compound, a common compound is H2O. 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 This is made up of hydrogen and oxygen. H2O is made of hydrogen and oxygen. You see, 2H2 plus O2 gives 2H2O. Hydrogen is a gas at room temperature, oxygen is a gas at room temperature, but water is a liquid at room temperature. Hydrogen is a gas, oxygen is a gas, but water is a liquid at room temperature. See, this water has entirely different property as compared to this hydrogen and oxygen. Hydrogen and oxygen are called the constituent elements from which this compound is made. So this compound is made from what all things? Hydrogen and oxygen. This is a gas, this is a gas. But the newly formed water is a liquid. Hydrogen is combustible, means it burns. It burns with a pop sound, we know. Hydrogen is combustible. Oxygen is a supporter of combustion. But what about water? Will it catch fire? No. Will it support combustion? No. Instead, water stops combustion and is used as a fire extinguisher. So, my point is this compound formed is having entirely different properties as compared to the constituent elements from which this compound is made. So, compound is having entirely different properties as that of these elements or the constituent elements from which this compound is made. So, this is entirely a new substance. Now, during the formation of this compound, energy may be heat energy may be absorbed, heat energy may be released, or light energy may be absorbed, light energy may be released. So there is energy changes during the formation of a compound. Means a chemical reaction is taking place between these elements. So normally, normally energy changes will occur. Energy changes will occur. Now, this compound, water, this water is represented, by this chemical formula H2O. In it, two elements, hydrogen and oxygen are present in the ratio 2 is to 1. In the ratio 2 is to 2 is to 1, if you take the molecular ratio by weight, if you are checking the weight of this hydrogen and oxygen, The weight ratio is, you see H2O, H2O. 2 is to 16 means 1 is to 8 by mass. This shows that 1 gram of hydrogen can combine with 8 grams of oxygen. 1 gram of hydrogen can combine with 8 grams of oxygen, means to make this compound, elements will be combining in a fixed ratio. You take water from any country, you take water from America, Africa, Australia, uh, from any country. You take water, in that you will see hydrogen and oxygen are combined in the ratio 1 is to 8. So, irrespective of the source of water, you can take water from lakes, from ponds, from sea, from well, from tap, from river, from rain, any source. From any source you take water. Water is made up of fixed elements. What are they? Hydrogen and oxygen in fixed ratio by mass. What is that ratio? 1 is to 8. By mass. By mass. If you are considering the number of atoms, then 2 atoms of hydrogen and 1 atom of oxygen. 2 atoms of hydrogen, 1 atom of oxygen. 2 is to 1 by number. But generally we talk in terms of by mass. By mass. That is 1 gram. 1 gram, 8 gram. 1 gram, 8 gram. Means to make water, you need, if you are taking 1 gram, you have to take 8 grams of oxygen. That is what is meant by mass. By mass means gram you will be taking. So, whatever may be the source of water, whatever may be the source of water, the same compound always contains same elements. I told you, you can take water from rain, from river, from sea, from well, from lake. In pure form of water from any source, the two elements are present in the same fixed ratio. Same fixed ratio by mass, that is 1 is to 8. Means if you are taking 1 gram of hydrogen, you need 8 grams of oxygen by mass. So about these things we will study in the next chapter. I am taking some other example. I am making a compound from iron and sulfur. From iron and sulfur to make iron sulfide. Iron sulfide. Iron is, shining gray color. Iron is of shining gray color. Sulfur is a yellow powder. But iron sulfide is a black substance. A black substance. See, the compound is having entirely different characteristics as compared to the constituent elements. What are the constituent elements? Iron and sulfur. And these constituent elements will be in a fixed ratio by mass to form this compound. What is that fixed ratio? In 7 gram of iron and 4 gram of sulfur. 7 gram of iron and 4 grams of sulfur. If you are taking 7 gram of iron, you should take or you should have 4 grams of sulfur to make this iron sulfide. Means to utilize this complete 7 gram, to utilize this complete for to make this 7 gram of iron to react, we need 4 grams of sulfur. So you'll be getting iron sulfide. If you are taking 3.5 gram of iron, then you need 2 grams, you need only 2 grams of sulfur. Means the whole number ratio is 7 is to 4. Whole number ratio is 7 is to 4. And the compound has got entirely different properties as compared to these elements. So what is the definition of a compound? It is a pure substance. See, compound is a pure substance containing two or more elements. Here I have shown only two elements. There may be more elements. For example, another compound, calcium carbonate. In this, calcium is there, carbon is there, oxygen is there. Some more elements are there than two. So, a pure substance containing two or more elements which are combined together in a fixed proportion by mass. See, what is the fixed proportion by mass here? 7 is to 4. Fe is to sulfur is 7 is to 4. Hydrogen is to oxygen is 1 is to 8. Hydrogen is to oxygen is 1 is to 8 by mass. We say by mass means we are taking in terms of grams. We are taking in terms of grams. If you are taking in ml, we say by volume. But here we learn in terms of by mass. By mass. So, what is the definition of a compound? Definition: compound. It is a pure substance. It is a pure substance. Elements are also pure substances. It is a pure substance containing pure substance containing two or more elements. Two or more elements combined together. Combined together in a fixed proportion. Fixed proportion by mass. So it is a pure substance containing two or more elements combined together in a fixed proportion by mass. Whatever may be the source of that compound always contains same elements combined in the same fixed proportion by mass. The same fixed proportion, that is constant. Whatever may be the source, that proportion is constant. In the case of water, in the case of water, that is 1 is to 8 by mass. In the case of FeS, that is 7 is to 4 by mass. In the case of carbon dioxide, it is 3 is to 8. Carbon and oxygen are present in the ratio 3 is to 8 by mass. So, this is fixed. For water, this is fixed. For FeS, this is fixed. For CO2, this is fixed. So, that is what is meant by a fixed proportion by mass. So this is constant here. This is constant for this water. This is constant. This is the constant proportion for FeS. And this is the constant proportion. This is the constant proportion for CO2. CO2. About this, so this constant proportion we will be learning in terms of law of constant composition, that we will be learning in the next chapter about this law of constant composition. So, we shall study this constant composition. We shall study in the next chapter that these elements are combined according to a particular law, according to a particular law known as the law of constant composition. You take carbon dioxide from any place. You take carbon dioxide from any place, you will see in carbon dioxide two elements, carbon and oxygen, are present in what ratio? 3 is to 8 by mass. That means if you are taking 3 grams of carbon, you need, you should need, you must need, you will need 8 grams of oxygen. So, by mass, this is a constant composition, a constant proportion, definite proportion, a definite composition. Here again, constant composition, a constant proportion. Here again, constant proportion, a constant composition. This is by mass, not by volume, by mass, by mass, by mass. That's about the compound. Compound shows entirely different properties as compared to the properties of the constituent elements. What are the constituent elements in iron sulfide? This black substance, iron and sulfur. What are the constituent elements from which this carbon dioxide is made? Carbon and oxygen. What are the constituent elements from which this water is made? Hydrogen and oxygen. So the new substance has got entirely different properties as compared to the constituent elements. Thank you.